We're going to be talking about the valence shell electron pair repulsion theory and how to assign the geometry to that molecule. VSEPR is a model that predicts the 3D shape of a molecule that will minimize the repulsion between electrons in the valence shell of that atom. To determine the geometry, we have to draw a valid Lewis structure and examine its center atom. That center atom will allow us to determine how many electron groups are around it. That number is here on this chart. It is also referred to as the steric number. This chart also has the electron pair geometry and the molecular geometry. The electron pair geometry is the same as the molecular geometry when the center atom doesn't have any lone pairs. When we get to steric number 4 and higher, there will be one bold bond and one dashed bond. The bold wedged bond means that the atom is coming at you, and the dashed bond means that the atom is going away. So we have to try to imagine the molecule in a 3D shape. So this VSEPR chart will give us the geometry of the molecule and the bond angles. Let's take a look at the first example. Let's determine the geometry of NH4+. We have to first determine the Lewis structure. So there are 4 hydrogens from group 1 and 1 nitrogen from group 5. When we add up these numbers, we're going to get 9 electrons, but this is a cation, and cations give up electrons. So this molecule has a 1+ charge, so that means it's going to give up 1 electron. So 9 minus 1 is 8. So our Lewis structure needs to have a total of 8 valence electrons. So the Lewis structure looks something like this. Don't forget the brackets and the charge. Now, this is a valid Lewis structure because I am showing all 8 valence electrons and nitrogen is obeying the octet rule. Now I want to examine the center atom. I want to count the electron groups around nitrogen. There is 1, 2, 3, 4 electron groups and no lone pairs. So 4 electron groups refers to steric number 4, and no lone pairs on the center atoms refers to the tetrahedral shape. So I'm going to draw the tetrahedral shape. Nitrogen has 2 bonds in the plane of the paper, 1 bond coming at you, and 1 bond going away from you. I'm still going to use my brackets with the charge, and I have to name this geometry tetrahedral and a bond angle of 109.5 degrees. So when we describe the geometry, we should show the correct drawing, the name, and the bond angle. Let's take a look at the second example. We want to describe the geometry of BCl3. We have to start off with a Lewis structure. So 3 times 7 is 21. 1 times 3, because boron is in group 3, is 3. So we have a total of 24 electrons. The Lewis structure looks something like this. This Lewis structure has all 24 electrons. Chlorine is obeying the octet rule. Boron is an exception to the octet and does not need to obey the octet rule. So I'm going to examine the center atom, which is boron, and I want to count the electron groups around the central atom. 1, 2, 3. So steric number 3 with no lone pairs correlates to trigonoplanar. So I'm going to go ahead and draw the trigonoplanar shape. And it has the shape of trigonoplanar. with a 120-degree bond angle. Now, the Lewis structure looks a little different than the actual geometry because I'm attempting to show my bond angles at 120 degrees. So that is necessary. So I have the correct drawing, the name of the geometry, the bond angles. Let's take a look at the next example. Let's determine the geometry of SF4. There are 4 fluorines and 1 sulfur. So there is 34 electrons, and the Lewis structure looks something like this. So this Lewis structure shows all 34 electrons. Fluorine is obeying the octet rule, and sulfur has an expanded octet, so it's allowed to have more than 8 electrons around it. So I'm going to examine my center atom, which is sulfur, and I'm going to count all of the electron groups around it. 1, 2, 3, 4, and then the lone pairs are 5. So steric number 5 means trigonal bipyramidal, and it has 1 lone pair on the center atom, so I'm going to draw a sawhorse-shaped molecule. And 1 bond going away, 1 bond coming out, and lone pairs on the center atom. The name of the geometry is trigonal bipyramidal, and it has the molecular geometry name of sawhorse. And we have bond angles in this molecule that are less than 120 degrees and less than 90 degrees. So we need to show all of this information, the correct drawing, the name, the bond angles. Let's do another example. Let's describe the geometry of C2H2. 2 hydrogens plus 2 carbons is 10 electrons. The Lewis structure looks something like this. So this Lewis structure has all 10 electrons, and carbons are obeying the octet rule. So let's examine the center atom. This molecule has 2 centers. This first carbon has 2 electron groups around it. Notice that the triple bond does not mean 3 electron groups. It just means that that 1 electron group is bound to the carbon with a triple bond. Let's take a look at the second carbon. There's 2 electron groups around the center atom. So this has steric number 2, and steric number 2 just means linear. So the linear shape looks like this, and I'm going to write linear, and the bond angle is 180 degrees. Good luck and keep practicing.